In this how-to video, I will demonstrate the features and functions of the Water Quality Data Analysis tool by uploading and comparing two sets of water quality data in CSV form. This is the screen that you'll see when you first launch the app, and the first thing to notice is the three tabs along the top: Reference Dataset, Test Dataset, and Paired Sites Comparison. This app is set up to help you compare between a reference dataset, typically one coming from a verified and regulated network such as Environment and Climate Change Canada, and a dataset that you would like to validate, for instance one that came from a community-based water quality monitoring program. I will note here that the features and functions under both reference dataset and test dataset are the same and they can operate independently, but the Paired Sites Comparison tab requires that two files have been uploaded. This means that you can compare between two different files or upload the same file to act as both reference and test. The first main step in order to use this app is to provide some data in a CSV form. CSV stands for comma separated value. To upload your data, go to one of the two tabs, Reference Dataset or Test Dataset, it doesn't matter which you start with. Click on the drop-down and use the menu to select Data Upload and Properties. This will open the Data Upload and Properties page. On that page, you'll see a Browse button. Click on Browse and navigate to the directory where you saved your reference data file. Click on the file and click Open. Once the file has been added to the app, a preview of the CSV table will appear to the right. You can use the scroll bars and buttons to navigate around and get a sense of the structure and content of the data. The app requires the user to tell it where to find certain parts of information that are mandatory for any further use of the app. The components that have to appear in each line of the CSV file are the following: a unique site identifier for each monitoring station, a corresponding longitude and latitude in decimal degrees, and date information. The app accepts data in both long and wide format for both the Reference tab and the Test tab. For example, the file I've just uploaded is long. I can tell this because there's a column that contains all of the different water quality parameters' names, as opposed to each parameter having a column for itself. In this case then, I'll select long, and I will also need to tell the app where to find the column that has the water quality parameter names and the corresponding values that were observed. The app automatically searches the column names to try and pre-select the correct columns for each of these drop-down menus, but make sure to double check that they're correct. In this case, the app accidentally selected the X column in lieu of the correct longitude column. By clicking on the drop-down menu of any of these options, I can see all of the column names and select the one I want, or alternatively, type in the name of the correct column and click. When you're certain that the correct columns have been identified, scroll down to the bottom and press Submit Column Selections. You have to press this button before you move on so that the other features and functions in the app work properly. Now that the data has been provided and submitted to the app, the next tab that we can look at is Spatial Visualization. Again, don't move on to these next tabs unless you've added data. Since we started with Reference Dataset, we're going to stay in Reference Dataset. Click again on the Reference Dataset drop-down, and now click on Spatial Visualization. Depending on the size of your reference dataset, this page may take some time to load, particularly the map that's going to appear on the left-hand side. Once loaded, the map will snap to the spatial extent of the sites. So this spatial visualization page is really meant to help give you sort of a preliminary overview of your data and where it was collected. The map at the top left will eventually display the location of each unique water quality monitoring station listed in the reference data file that you uploaded, or the test data file if you're working underneath test data, based on the longitude and latitude columns you specified earlier using the drop-down boxes on the Data Upload and Properties page. If you scroll down, you'll see a table similar to the one on the previous page. This table also offers filters which impact what is shown on the map. Using this, and especially if your data is wide, you can actually see the numerical range of some of your water quality parameters. In order to see a basic scatter plot of your data at any station, simply click on the station you want to view in the map and ensure that you've selected a correct parameter that you would like to visualize. So let's stick with alkalinity and select a station on the map by clicking on it. Note that the station's unique identifier also comes up as well. And on the right side, there is now a scatter plot of date versus the parameter that you've selected in this drop-down column. The scatter plot that appears offers zoom functions, zoom in and zoom out, and makes it easy to take a PNG photo of the plot by using the camera button along the top. If you hover over this icon, it says download plot as a PNG. Simply click once, and the File Explorer tab will open up, allowing you to browse to a correct directory and save your plot under whichever name you would like. In this case, though, I'm going to choose not to save. To escape, hit cancel if you don't want to save. The next tab under the Reference Dataset or Test Dataset dropdown is the graphic visualization. You access it the same way by clicking on Reference Dataset or Test Dataset if that's where you're working, and clicking on Graphic Visualization. As a side note, if or when you want to return to a page that you've already worked on during this session, your last inputs will still be there. For example, we can go back to Spatial Visualization and we see that that scatter plot is still there and the same site is still selected. The menus on the graphic visualization page can be a little busy at first, but we'll go through each part individually. First, you get to select between univariate, single variable, or bivariate, two variables. For example, if you wanted to look at only the distribution of, say, alkalinity, you would use univariate. If you wanted to visualize your alkalinity date across time, you would use bivariate, with your date column as the x or second variable. Let's start with a univariate example. We make sure that number 1 is still selected. The next step is to choose which of your sites you want to include in this graphic. Let's pick 3 or 4 for this example so we can actually compare between them. Next, we have to tell the app which dates we want to see. This way, you can track changes in a single month, across multiple years, or compare between months in a single year, or any other combination or isolation you're interested in visualizing. Scroll down to see more options, and use the checkboxes to select which months and years you'd like to include. Let's look at data from March to August in the past 6 years. March, April, May, June, July, August, 1, 2, 3, 4, 5, 6. Since we selected univariate, there's only one drop-down variable selection box for your water quality parameters. Let's stick with alkalinity, although you can see here that your other parameters are accessible as well. The next necessary choice is what type of plot you want, with options for whichever number of variables, 1 or 2 you selected earlier. Use the radio buttons to select which plot type you want. I'm going to choose density. The box below gives you an option to set a name for your plot. I'm going to write alkalinity test. You can also type in units below. Note that this will not change the raw data values. Now, click Refresh Map and Update Settings and scroll back to the top to see your graph. And there it is. Let's do a quick example of the bivariate interface. Go back to the top and use the drop-down menu to select 2, meaning bivariate. You'll probably notice a change to the right, but just continue on with your selections like before. I'm going to maintain the same sites and the same date range. When you get down to the variables, you'll notice that there's now a second box labeled Select Variable to display on your x-axis. This extra box was added because we're now working in a bivariate situation. I'm going to use date as the second variable, and I can search through by typing. Click again, refresh map, and update settings. And also note that you have options in terms of the bivariate graphs as well, point, line, and discrete box plot. I'm going to start with point. Keep an eye on your data types when you're making this choice. The discrete option should only be used with discrete or categorical variables, not numerical or float variables. Click again to refresh and submit. Now we've generated a point scatter plot, and we can see that the data is colored based on site name, taken from the site identifier column that we specified on the Data and Upload Properties page. If you want to download your graph, scroll down to the bottom and click on Click to download your plot. Navigate to where you want to save the file, change the name if you want, and hit Save. If this happens and it doesn't download, simply click on the little download signature and allow your browser to save. The next tab from the top drop-down is Statistics. You know what to do. Again, the page will take a moment to load. Once it does, let's take a look at what's going on here. There are two tabs, Summary Statistics and Normality Testing. There is also a box to select a water quality monitoring station and to select a water quality parameter. Thus, the stats given here, which include minimum, first quartile, median, mean, third quartile, and maximum, refer to the specified parameter at the specified site. Scrolling down, that parameter at that location is also graphed in box plot form. The first box plot has all of the selected data. The second one breaks the data up by month, and the third and final box plot breaks the data up by year. The second and third graphs have download buttons in the same way as on the graphic visualization page. And the first graph can easily be generated and downloaded on the graphics visualization page as well, using the univariate option. Each time that either the location or the parameter is switched, the box plot graphs automatically update to reflect the change. Moving on to the Normality Testing tab, click on it. This page may not be useful for everyone. It's basically a preliminary check on the normality of your data that's good to do prior to using any more advanced statistical tests that may assume normality or require that your data not be normally distributed. The same selections that you made on the Summary Statistics page in terms of your site and your water quality parameter will be maintained here, but of course you can switch your site and or your parameter of focus. It automatically displays a histogram of the distribution of your data, and below that there are results of the Shapiro-Wilk normality test for the raw data and for the log transformed data. If you're not familiar with statistics, don't worry too much about this. The next couple of comments are just additional details for the sake of transparency. The Shapiro-Wilk tests were done in R, and the confidence interval is 95%. As such, the threshold value for P is 0.05. If the p-value listed is less than 0.05, that means we can assume that the data for the selected variable at the selected site is significantly different from a normal distribution. We can apply the same criterion to the log transform data. If the p-value is less than 0.05, as it is here, we can assume again that it's significantly different. Keep in mind that the number of data values, n for all you statisticians, has an impact on how accurate this test is. So don't assume that this specific test is appropriate for your specific dataset. That finishes up the Statistics tab. Let's move on to Temporal Coverage Summary, navigating the same way we've seen before with the other drop-down choices under the Reference Dataset tab. This page also generates graphs, but it focuses more on the dates of data collection. If you're looking to see what times are sampled more than others, or you want to get an idea of what your period of record is, or if you just want to brag about how much data you've collected, this is probably a good tab for you. You have three options. A is Single Site Summary, which means only data from one water quality monitoring station, all parameters. B is Complete Dataset, so all stations and all parameters. And C is Summary by Groups, which means you can break the data up by, say, discrete regions or sections, and compare your observation numbers between those regions. If you do select the radio button C, you will be prompted to tell the app which column has the discrete group names, whether that's groups, regions, jurisdictions, or howsoever you may have decided to spatially subdivide your monitoring area. I'm going to use the province and territory column in this dataset as an example. Once you've selected which column includes your group names, you're going to be prompted to select a group. If no options appear, simply click on the Refresh Plot button, and then ensure that you've selected the group that you'd like to look at, and click Refresh Plot once more. Thus, you see observation counts broken up by month and color-coded by year, with the number of observations along the side. Let's try the Single Site Summary, option A. Use the radio button to select A, and you'll see your menu change to reflect that, giving you a chance to pick your target site. Again, use the drop-down menu by clicking and pick the site that you would like to see. Click Refresh Plot to reflect your changes. Complete Dataset Summary can be accessed the same way by clicking on B and clicking Refresh Plot. So we can definitely see the changes from month to month. And as always, there's that little download button for you to click on and save your graph. So that's it for the functions that draw from a single data set. Before I move on to the Paired Sites Comparison tab, I need to add a test dataset file. Again, conceptually that could be your needs validation community-based monitoring dataset, so that we can actually do this inter or intra file comparison. The process for adding a test dataset is the same as that of the reference dataset, only now you use the test dataset dropdown, or if you started with test, now you'd be using reference. Click on the dropdown and go to Data Upload and Properties. Browse, add your data, check your columns, make sure you've got the correct format, and again, click on Submit Column Selections. I'll reiterate that this app automatically compensates for both long and wide data formats, as well as a variety of date formats. This particular community-based monitoring dataset was obtained from the Mackenzie DataStream website. Note that it's actually in wide format, with each individual water quality parameter occupying its own column. Because of that, I'll make sure that the wide format is selected and hit Submit. Now we can finally move on to the final part of the app, the Paired Sites Comparison page. Again, we'll go from the top drop-downs and click on Site Pairings. The first thing that you want to notice about this page is the text entry box at the left. This is asking you to tell the app just how close together do two sites, one from the reference file and one from the test file, have to be to count as a pair. The text is there. Pairs will be generated following input of buffer distance, as a little reminder that for this to work, you do have to specify the maximum distance. The units are kilometers, and keep in mind that this is Euclidean or straight line distance, proverbially as the crow flies. I'll try 2 to start. Once I do that, all of a sudden these other boxes pop up, which we'll go through one by one. What you want to look at now is the table at the top, which lists the generated pairs based on the maximum distance in kilometers that you specified in the text box. In this case, there are 5 available. The station unique IDs are given for both the reference stations and the test stations, as well as the distance between each pair. And they're also automatically assigned a pairing number which corresponds to the row in the table. Whichever pair you've selected from the first box, that would be the top left drop down, will automatically be shown in the map over to the left. Let's choose site pairing number 2. This is a good example of a fairly ideal situation where you have the 2 stations on the same channel. Euclidean distance doesn't always guarantee that, so that's something to keep in mind. By clicking on the station, its ID will be displayed, so we can easily tell which of the 2 markers is the reference. In this case, this one is the reference, and which one is the CBM. In this case, this is the community-based station. For the boxes in the main area, you should proceed left to right and then top to bottom. This means that next you're going to select a parameter from the reference dataset and the corresponding parameter from the test dataset. This can get a little tricky if naming conventions aren't consistent, so make sure you're actually comparing 2 matching parameters. Some things to keep in mind are collection methods, details in the metadata, and especially units. This page assumes that the units are the same for each pair of parameters. I'm going to say that again for emphasis because it's really important. This page assumes that you are comparing between the 2 files based on the same parameters measured using the same unit. If you're not sure, go back to the original files and look for a units column, or check your metadata, or if you have to, find out from the data collectors themselves if that's possible and or appropriate to do. Getting back to the boxes, let's select some matching parameters. I'm going to look at pH. The next step is the box on the bottom left. The method on this page compares the test data of a month across all years to the reference data of that same month across all available years. In this case, we can test June, July, or August. The options in the month selection box here are limited based on the availability of test data for the parameter you specified in the top right box. Based on the test month that you pick in this box, be that June, July, or August in this case, the timeline for the reference data set, years included in the slider's range from the reference, will change, again based on data availability. Overall, it's better to have a long period of record from your reference data set, but if you do want to alter it, you can do so using the sliders. So let's stay with July and let's use as many reference years as possible. Once everything is checked, selected, and in place, you're ready to make the comparison. Locate the Click to Compare button on the left just below the map and click. 2 things show up at the bottom of the page and you will probably have to scroll down to see them. A box of text and a plot. The text here reads, the test data could be near the edge of the normal range of the reference data, but it likely falls within the normal range of the reference data. Look at the graph below to see the data being compared. And oh look, another reminder about those units. Remember that for this test to work, the variables and units must work. And keep in mind that the terminology in the text here, especially could be and likely, is because there's absolutely some uncertainty associated with this sort of comparison. The graph down below shows the data that was compared. Date on the x-axis your parameter values on the y-axis, and the points themselves color-coded based on whether they're coming from reference dataset or the CBM dataset. To finish up this explanation of the paired sites comparison page, I would just like to show you where this comparison methodology is actually coming from. It follows the procedures outlined in a published journal article, this one here, Kilgore et al. 2017. That said, again, I'm going to reiterate that this is a pre-alpha version of the app, and as such is still being validated, fixed, and updated. So please don't base decisions on these outputs. Please follow any and all other rigorous scientific and procedural steps for data analysis and decision making that you may have already established for yourself, for your organization, or for any other purpose. Once again, this is a pre-alpha version of the water quality data analysis tool. This concludes the how-to video. Thank you for taking the time to watch and to help develop this free resource.